Assalamu alaikum, Dr. Kavar. I'm Daud Tanveer Gill, a student of polymer chemistry. Today I will discuss some of the various polymerization techniques. These are the techniques: bulk polymerization, solution polymerization, suspension polymerization, and emulsion polymerization. I will just start with the bulk polymerization. As it is evident by the name, bulk means mass. It is also known as the mass polymerization. In the bulk polymerization, we only have the monomer and the initiator. Initiator is also called as polymerization starter, like it is written over here. A homogeneous mixture is formed in this react. In this case, the initiator starts the reaction. It initiates the reaction by forming many radicals, and then they propagate, and the termination step occurs at the end. We finally get the polymer. Again, in agitation and some heating is also done at constant temperature. One problem is that this reaction is highly exothermic and there is no efficient control of heat. Heat has to be dissipated out so that the reaction kinetics can be maintained. There is a problem in this polymerization. Some advantages are that the polymer formed is high in purity and has high optical clarity. As the reason of purity is that nothing else is present, only the monomer and the initiator. I will now discuss the solution polymerization. In the solution polymerization, there is monomer, initiator, and the solvent. The initiator is soluble in monomer. A heterogeneous mixture is formed. The reaction mixture is agitated and heated to a certain temperature with constant heat. So the reaction begins with the initiator, radicals are formed, and so on. It ends up till the termination step. We get the polymer. It has the advantage. The solution has a lower viscosity. It helps in mixing up the reaction mixture. Also, अब इसमें एक बात का ख्याल रखना ये भी इम्पोर्टेंट है कि जो हम सॉल्वेंट जो हम यूज कर रहे हैं उसका जो बॉइलिंग पॉइंट है वो पॉलिमराइजेशन टेम्परेचर के इक्वल होना चाहिए. इफ इट इज नॉट इक्वल तो एज अ फैक्ट ये होगा कि आपका जो सॉल्वेंट है वो पहले वेपोरेट हो जाएगा और सेम डिफिकल्टीज जो हमें फेस हो रही थी बल्क पॉलिमराइजेशन में वो इसमें भी होंगी. सो दैट हैज टू बी टेकन इनटू अकाउंट. बाकी ये है कि द डिसएडवांटेज इज दैट we also have to get rid of the solvent, and for that we have to do further separation techniques like distillation and centrifugation. It is a costly method. uh, Now I will talk about the suspension polymerization. In the suspension polymerization, again there is a heterogeneous mixture. There is monomer, initiator. They both are soluble in each other, and there is water, the aqueous layer. The initiator, as we can see, is represented by the red dots. The reaction mixture is agitated and heated to a certain temperature. Very special thing about this is that the polymer formed has a shape uh, of pearls or beads that is spherical. The spherical beads are the special characteristics. We often get the beads in the size in the diameter of about 10 to 100 micron meters, which is its speciality. And the polystyrene beads are the best example of this reaction. It has its इसकी काफी बड़ी application है. They are used as ion exchange resins. Then thermocol is also formed from this polymerization technique. Various other things can also be produced. So now I will move towards the emulsion polymerization. In this, we have the initiator monomer. The way in which it differs from the suspension polymerization that it does not require physical or mechanical agitation like in the अब यहाँ पे हमारा surfactant वो काम करता है. We add up the monomer, the initiators, suspending agents, everything in the water, and a heterogeneous mixture is formed. अब जो surfactant है वो हम देख सकते हैं कि it has a tail, and that tail is hydrophobic in nature, and the head is the hydrophilic. When it comes into contact with the water, it turns into a micelle. We can see the structure of micelle over here. These lobes or circles are hydrophilic in nature. In the center, we have the hydrophobic region. अब होता ये है कि we have the initiators. They start producing radicals. The radicals start to penetrate from the aqueous layer into the micelle, which is the hydrophobic region. These radicals start to join up together via propagation steps. Then in the propagation step, we have the growing polymer chains, and finally, a time comes when the reaction is terminated in these mycelial cells. A macromolecule is formed, a large polymer, we could say. अब वो जो मैक्रोमोलिक्यूल है वो हमें फिर अब सेपरेट करना पड़ता है, तो वो ये आप देख सकते हैं. This is a macromolecule. It has to be separated out. So we get the polymer. It has many advantages. Like इसमें viscosity buildup negligible होता है, and there is it is not that expensive like the previous ones. However, there are some disadvantages like इसमें impurities थोड़ी सी होती हैं, emulsions various types की आ जाती हैं, like surfactants particles remains, उनके remains भी रह जाते हैं, और emulsifying agents होते हैं, impurities separate out करनी पड़ती हैं. So that was all of it. Now I will be asking a few questions from you for my guidance, and these are the questions. Uh, like why condensation polymers cannot be formed from these, and which method is the most environment friendly, and in the bulk can a monomer impurity be left in a polymer, and how could we separate it? So these are some of the questions I would like to ask. So thank you so much for watching my video. I hope you liked it, and Allah Hafiz.